Good day, everyone. This is my report all about moments. What is moments in statistics? In statistics, moments are quantitative measures used to describe the shape and characteristics of probability distributions. They provide insights into various properties of a distribution, such as its central tendency, dispersion, skewness, and kurtosis. What are the different types of moments? The first one is the first moment is the mean or expectation. So the mean or expected value of random variable. It provides the central location or average value of a data set. Example, calculating the average income in city helps to understand the typical earnings of its resident. Second moment, the variance. Measures the dispersion or spread of a distribution around the mean. It assesses the variability or spread of data points. Example, variance helps to understand the consistency of test scores among students. Third moment, the skewness. It measures the asymmetry of the probability distribution of a real valued random variable about its mean. It indicates the direction of skew, left or right. For instance, skewness helps in assessing whether the data is skewed toward higher or lower values. A positive skew suggests a long tail on the right, while a negative skew suggests a long tail on the left. And the last one is the fourth moment, the kurtosis. It measures the tailedness of the probability distribution. The propensity of data to produce extreme values are the outliers. It helps to understand the extremity of outliers. Positive kurtosis indicates heavy tails or outliers, while the negative kurtosis indicates light tails. Example, high kurtosis in financial returns can signal a higher likelihood of extreme returns. So let's have an example. So we have here a problem. Illustrate how moments are used to analyze student performance data. Suppose you have collected exam scores for a class of 20 students. The exam scores are 45, 55, 60, 65, 67, 70, 72, 73, 75, 77, 80, 82, 85, 88, 90, 92, 95, 97, 100, and 105. So this is our problem. So we will find first the first moment, which is the mean or the average score. For our calculation, the mean provides the average exam score of the students. So we will just add all the scores and divide it to 20. So our total score is 1,627 divided by the number of scores, which is 20, equals to 81.35. So the average score of the class is 81.35. This helps teachers understand the general performance level of the class. So that is our first moment, which is the mean. So the next one is the variance calculation, or our second moment. Compute each score's deviation from the mean and square it. Average these squared deviations. Let's perform this calculation. So in our variance, we will subtract our mean from our individual score. So example, So one of our scores is 45. So minus the mean, which is 18.35. So their difference, the we must square it. So that is 1,303.9225. And then again, 55 minus 81.35 quantity squared, that is 693.9225. And next is 60 minus 81.35 quantity squared, that is 458.1225, and so on. And then we will have sum of square deviation. So the answer here, we will just find for the sum. So that is 16,674.2. And then we will divide it by 20 by the number of scores. And the answer is 833.71. So the variance is 833.71, indicates a moderate speed spread of scores around the mean. The higher the variance, the more varied the student performance are. So that is our second moment. So our third moment is our skewness. So the third moment is skewness, which measures the asymmetry of the data distribution around the mean. It is calculated as, so this is our formula. So we will find for the sum of cubes. So that is negative 5.564. So our skewness of the distribution is approximately negative 0.292. So for our interpretation, the, the skewness value is approximately negative 0.292, which indicates a slight negative skew. This suggests that the distribution of exam scores is slightly skewed to the left, meaning that there are more high scores than low scores, but the skewness is quite close to zero, indicating that the distribution is fairly symmetric. And the last one is our fourth moment, which is the kurtosis. So this is the formula in finding for the kurtosis. So our kurtosis is negative 0.381, suggests that the distribution is likely platykortic. So this means that the exam scores are fairly evenly distributed, with fewer students having extreme score far from the mean. So the distribution is relatively flat compared to a normal distribution, indicating that most students scored around the middle range with a fewer high or low outliers. For our overall interpretation, so the student exam scores are generally well distributed around the mean, with a slight tendency for higher scores. The slight negative skewness indicates that there are more scores above the mean, but the distribution is nearly symmetric. The negative kurtosis suggests that there are fewer extreme scores than expected in a normal distribution, meaning that the performance is relatively consistent with fewer outliers. Overall, the data suggests that most students performed around the average, with a few scoring significantly higher or lower. So that's all for our moments. Thank you.